LeetCode question number 747, network delay time. This is medium question. Let's get into it. There is n network nodes labeled 1 to n, given times a list of travel times as directed edge times I, u, v, w, where u is the source code, v is the target node, and w is the time it takes for signal to travel from source to target. Now we send the signal from certain node k. How long it takes for all node to receive a signal? If it is impossible, let -1. Okay. What is the case of lit -1? Yes, that's right. There is another node 5, and then this node did not have any edge. At that time, maybe signal cannot go into this one, so we need to return -1. Okay, now case 2, case the start time, and then n is 4, 1, 2, 3, 4, and then after pass the 0 to 1 second, maybe this signal going to not only here but also here, and then now 2 seconds, maybe this one cannot going anywhere, but this one is going to here. So 1, 2, 3, 4. Now every node received signal, so we need to return 2. How are we gonna do that? Okay, today I gonna use Dijkstra algorithm, that is minimum weight path search. Commonly GPS navigation use this algorithm. So and then if we implement Dijkstra algorithm, normally we are able to use heap, the min heap, and then put the from start node to current node the time put here, and then if time is the bigger than smaller than this one, it will update it. Okay, I will drawing. Okay, let's say there are node 1, node 2, node 3, and then this is path 1. Another path is if going to node 4, and then it also going to 3. This time this node weight is 1, and then this is 5, and then this is 9, and then this is 2. At that time it starts traversing this first, and then now node to take time is 1, and then here is take time is 10, right? And then there are another route, this time going to 5, and then this one 2. So now this one is updated 7, and then this path is the shortest path. Does this make sense? Okay, let's implement the code. So first we make the graph. I will use collection, default dig, and list, and then we need the heap. Then import collection, and then heap, and then heap I will put the start node, this one. At that time this one time is what? 0 time, and then node k. And then which one is first? This one is first because we will sort by the time, right? So I will do time and node, and then this is start time is 0 and node is k. And then we also need to visit it. At that time I will use the hash map instead of set, because we also need to store the minimum time to the certain edge. So okay, now it's time to traverse graph. While heap is not empty, I will pop time, and current node is I will pop And then if current is not visited, I will add visited current is time. And then I will move the next. Next time is, which one is good? And time. Time and next in graph current. And then, okay, let's put the heap queue, heap push, and the heap, and then, okay, next time is the we put the only the next time. No, because okay, let's say now here we are here, and then this one time is 1, and then end time is only indicated this one. So if it is 1, and then this 1 plus the previous time. Previous time is time, and then next time. So we are still have to add next time plus current time and next node. And then, okay, return. Just return the maximum visited values, right? And then we are also able to edge case handling. If there are one node to 5, and in this case we needed to return -1, right? So to do that, I will check. How are we gonna do check? Yeah, that's right. We just check the length of visited, because in this case length of visited is only this one, right? So this one number is 4, but length of node is 5. So this one is does not same. I will return -1. Length of visited is n, else -1. Okay, let me check the typo graph. Okay, heap visited, heap time current, heap buffer current visited, next time is next. Okay. Wrong answer. Okay. Now case visited. Time and current visited pop heap. Current visited current is time. Okay. Next time and time, and then next. is -1, so okay, for 2 length of visited is n as -1, that means we did not visited. I did not make a graph. Ah, no way. Okay. UVW, right? I will get times and then graph. I will do same way, time and node, so W and U. Oops. graph, 아이고. graph V is W, right? W, U. That is time and node. Those two matching to this one. W, W, U, U, V. Okay, alright. Okay, looks good. Okay, let's check time complexity. Time complexity is big O. In this case, to do that, this is n, and then if we use heap, normally we use n, and then in this operation, heap also use multiply n log n, right? And then plus h. So we can say n square log n, and then space complexity is big O n plus e. So now I would okay. Now that I will optimize or make it a little bit better. That is, I did not use the heap, and then some people that asked me, oh, you said if you use the Dijkstra algorithm, you need to use heap, right? But in this case, we can use another approach. Yes, that's right, the backtracking. If we use backtracking, we do not use heap. So we are able to replace it to Q. And then corrections, DQ. And then we need it to be visited, and then we need the one list node is 0. But we will check only the minimum number to the node. To do that, the initial width, that's right, float infinity, and I will n plus 1 to matching label 1 to n. So I will not use node 0, and then start node must be time is 0. Then okay, change the Q, and then we'll change Q pop left. Then okay, and then I will use this one first. Then I will, in that time I will, okay, next time I will add the current time, that is final destination time, right? So if next time is smaller than node the next current time, that means 1, 2, 3, and then this one is 2, 7, and this is 4, then this is 5, 1. So in this case here currently I have 2 plus 7 is 2, 7, so this is 9, right? And then another way is 5, 1 is 6. Only this time we have needed to update it to 6, right? So that is the reason why initially is INF. Okay, so only in this case I will update node next is next time. And then okay. Then I will append the queue. Then I will delete time because I already implemented it, adjusted it. Then next. Now how we able to check it? Yeah, that's right. So if the some node is does not visited, what is its value? This one is INF, right? So if there are node not visited, it has the INF. So I will check the node is the node had item of node is INF. I will return derivative 1. So for n in node, and if n is float INF, I will return -1. Otherwise, return max node. Okay, let me quick check. Okay, typo, not typo, only okay, float -1, VW, WV, V, W, VW. Okay. Q current time, palm left, next time is current, next time is next time is. Okay, looks good. Okay, good. Now we do not use heaps, so in this case here is big O 1, right? So we able to delete this one. So finally, now solution is the n square plus e time complexity. Space complexity is node plus number of node plus number of edge. Thank you.